All right, logarithmic functions today. I want to just do an introduction to it. No really long problems on this, but understanding what they are, where they come from, and a couple different ways that we can see a logarithmic function. So the definition of a logarithm is a logarithm basically of a positive number x satisfies the following definition. So very important what I'm going to write right here. Okay, this is my logarithm. Y equals log base b of x is the way that I say this. Okay, say it right here. And what I do is I relate it to what we just did with exponentials. What happens is this b comes over and it bumps up the y on the other side. Okay, and that gets rid of the base. So that b is still a growth factor. It's just that now that I'm doing a growth factor underneath my y instead of my x. So it's the same thing I've been doing, I'm just switching my x's and y's. And so just moving that b, that base, back and forth is the first thing I want to work on. I want to be able to go from an exponential form that we've seen to a new logarithmic form. All right, so again, this 4 right here is my base. And what I'm going to do is I'm going to send it to the other side to be the base underneath my logarithm. There's a lot more to it than that. In the next couple of videos, I hope that we're able to go deeper into this to see why that happens. And eventually next week we'll be able to solve. But what happens is when that 4 comes over, that 2 drops down, and I just get the equation log base 4 of 16 equals 2. Let's try it in reverse on part B. Okay, now the 3 was over here underneath the log. It's going to go over and it's going to move that 2 up to the exponent. So that now instead of 3 being the base underneath the log, it's the base underneath the exponent. That gets rid of the log on this side. And I'm just left with the exponential equation 1/9 equals 3 to the negative 2. Pause the video, you try part C and D, and it shouldn't take very long. And that's what I got from my answers. Now, what I want to be able to do is I want to be able to evaluate logarithms before we leave here. Okay? And so I like to be able to do this mentally. Right? So I ask myself a question, just like Dwight Schrute here. So it's a question. To what exponent should b be raised to in order to get x? So even though I'm doing logarithms, I'm still thinking of them in terms of exponents. So for example, in order to get, what's that red dot? I have no idea what's going on up there. I want to ask myself, not what is log base 3 of 81. Instead, what I'm thinking on this one is, okay, if I take 3, and again, remember, 3 comes over to this side. So 3 raised to what power? Or you can put a y there, is equal to 81. So I might need to go to my calculator on that one. But I know that 3 raised to the 4th power has to be 81. Therefore, log base 3 of 81 is equal to 4. And so I can go through and do a lot of these in my head. 2 raised to what power gives me 1? Only thing that is 0 power gives me 1, so the answer to this would be 0. On part C, I kind of got a little bit harder down here. On part C, 100 raised to what power gives me 10? 100 raised to what power gives me 10? Well, the square root of 100 is 10. And so the square root as a rational exponent would just be 1/2. And so 100 raised to the 1/2 gives me 10. If you don't believe me, type that in your calculator and see if that comes out. I want to pull part D over here on this side. Right? Part D, I'm asking 2 raised to what power gives me 1/64. So they're thinking, man, 2 raised to what power gives me 1/64. Going from 2 to a smaller number, that's tough. Let's think of it this way. Let's use my rules of exponents. Remember, if I have a negative exponent on this 2, all I have to do is drop it down to the bottom, right? That's how I go from a positive exponent to a negative exponent. I either bring it up to the numerator or drop it down to the bottom, and it switches signs on this. I think this makes it a little bit easier to see. Because whatever I'm raising 2 to, it has to be negative in order to make it so that this 2 matches up on bottom. And so if I think about it, 2 raised to what power gives me 64? That should be the 6th power. And so my answer will be -6. Sure enough, 1 over, or 2 to the -6 is 1 over 2 to the 6, which is 64. So this -6 would be my answer. So just in general, the only time I'm going to have a negative in my answer is whenever I'm going from a fraction to a whole number, or like I did here, from a whole number to a fraction. And so you can automatically just assume that there's going to be a negative in there. And you can almost just omit the fraction part that's in the way. So I don't have to worry about that 1 over anymore. I can just think 7 raised to what power gives me 2,401. And that would be to the 4th power. So that means that 1/7 to the -4th power would be the same as 7 to the 4th power if I flip it to negative exponent, which gives me 2,401. So -4 was my answer. A little bit confusing on that. I'm not trying to make it confusing. I'm wanting you to see the relationship between logarithms and their exponents. Now, we use base 10 for counting, and so this log base 10 came up a lot whenever logarithms came along. Okay? Log base 10 of x. And best that I can tell is that the mathematicians got really tired of writing log base 10. And so they got lazy. Mathematicians can be lazy at times. And they quit writing the 10 down there, just wrote log of x. And so everything still follows the normal with this. For instance, and if you want to, you can come down here, right, with y equals log base 10 of x anytime you see it. On my quizzes and my tests and in the homework, you're not going to see that 10 down there. You're just going to see log of x, and it's got to automatically trigger in your mind that that 10 is down there. Okay, and it's still equivalent to if that 10 was to round over and bump the y up to the exponent, it's still equivalent to 10 to the y is equal to x. So let's try a couple of these. There's that red dot again. All right, so I want to find the value. Okay, notice this one doesn't say mentally, so I have a shortcut coming in just a little bit. But this first one I think we can do. Okay, remember, there's just a 10 down here. So I'm wondering 10 raised to what power gives me 100,000? Well, a little shortcut that I hope that you've already learned is that 10 raised to a power is just going to tell you how many zeros come after the 1. And so the answer to this one would be 5. 10 raised to the 5th power gives me 100,000. Therefore, log of 100,000 is equal to 5. So this log base 10 really only works whenever I have some multiple of 10 going on. Or some, I guess, multiple of 10. If I have a 10, 100, 1,000, 10,000, 100,000, a million, and so forth. So like this one that says log of 1,116, that's really hard to think of. 10 raised to what power gives me 1,116? That's not going to be a nice number at all. So what they've done is they've given you a log button on your calculator. And that log button on your calculator is probably on the left side somewhere. And you just hit log and it's going to open parentheses and you can just put that 116 in there. And I'm just going to keep it normal to 3 decimal places, 3.048. So that means if I was to take 10 raised to the 3.048, I would expect my answer to be close to 1,116, just like I did on part A. Let's try it on part C. If you want to get ahead of me a little bit, you can. I don't have the fastest fingers. Let's see, 0.419. Probably going to be a negative number since I have a number smaller than 1. And sure enough, it is. We'll just keep 3 decimal places on it. What's that, 378? And that would be my answer. So we like those problems. Look for those problems. They are going to be coming up in the homework and possibly on your quiz later this week or next. Well, Euler wanted in the game. Remember Euler, that Swiss mathematician that came up with the number E, 2.71828? We use E a lot, this natural base a lot, whenever we are dealing with exponents and logs here on out, pre-calculus, calculus, and upper level math. And what we're going to do is, instead of having log base e of x, because we're going to use it so much, we're going to have a shortcut for it as well. If you look close to your log button, you see something that looks like ln. All right? Please don't call it ln. That makes my skin crawl just a little bit. I'm going to call it the natural log of x. It's called the natural logarithm because we're using the natural base e as the base. And so everything still flows with this. If I have y equals natural log of x, you can think of it as log base e of x, and then the e can come over. And so this is going to be equivalent to e to the y equals x. Now, since e is this weird number 2.71828 that we found, we're going to have to be using the natural log button on our calculator anytime we see a natural log. So go ahead and find that natural log button, type it in, and see if you get the same answers I'm going to get. Go ahead and pause the video and hit play when you get your answers. Hopefully you got 4.812 for the natural log of 123. And something weird happened on this. I typed in natural log of something negative, 123, and I got a no solution on there. Probably said domain error on your screen. So we have some domain issues that's going to come up with the natural log. We'll save that for a later video and not today.